So the objective of the fatigue loading test is to characterize the fatigue performance of materials by using the Waller diagram, or also known as the SN curve. And so what we're going to do with this machine is we're going to put different stresses on the material and just create a back and forth cyclic loading on the material, and it's going to run at really fast speeds and keep count of how many cycles it makes until it breaks. And what you'll see is that under certain load, under a high load, it'll take less cycles to break, but there will come a point where the load is so low that your material actually never breaks. And so the material that we're going to be using is these right here. And one thing that's important to note on the specimen is there will be a little number that is pinned onto it. And it will be a 1, a 2, or a 3. And this is going to be critical whenever you are looking at your lab manual and selecting the correct material to test. Now we're going to come over here and load the material into the machine. The first step that you need to do is whenever you are holding the device for loading, where the threaded ends are, you are going to insert the material in like that. The second thing that you want to do, this is the spring that applies the load to the machine. You want to make sure that it is all the way down. Once it's down level with the machine, you want to take the tail of the specimen and load it through. And once it's all the way through, you're going to come forward and make sure that it loads into the machine here. And then you are going to take the cover, you're going to start threading it on. At this point, you want to be very careful not to cross thread and do not put any torque on it. If you're feeling any type of resistance with the threads, do not go further and do not apply the wrenches to it. You should be able to hand tighten onto the machine. Be warned, you will get some oil on your hands. Now, once you're here, you're going to take your 2 wrenches. You're going to set one of them right here and one here, and you're going to just keep moving it until it is completely tightened in, and you want it to be pretty snug. After this, you will set the cover over the material, and then we come over here, make sure that the light is off. That means that the emergency switch is on. Whenever you take it back off, you will see the limit. That is just the cyclic loading that it's going to take, and then your force in newtons, and then your N is the number of cycles. So right now, the force is saying around 20 newtons, and you will see it also on the computer, which you will demonstrate in lab. So at this point, what you do is you begin to run the screw and just begin to tighten it. And you'll see that as you tighten it, over here on the screen, your force will go up. You'll see in your lab manual the forces that you're supposed to run the gauge up to, and it is a little bit tricky to get it exactly where you want it, but with patience, it will get there eventually. For the sake of this experiment, we will try to get it close to 200 newtons. So once it's about plus or minus 5, you can call it good to go. So then from here, you'll move to the application and hit the start button. If you're not using the computer, then you can just go ahead and press go by pressing this switch down. So I've only paused the machine because we don't have to run the whole experiment in this video, but this will run until the material breaks, and the machine will keep the number of cycles that it goes until it fails. When unloading the specimen, the first thing you want to do is make sure that your emergency switch is pressed down, and you'll know that it's down whenever the screen is blank. So when you come over here, just like when you were loading it, you will use your wrenches to break the torque. And you'll notice once you undo the cover, it might be stuck. What you want to do is rotate the arm where that hole is visible, and you'll see in the tool pouch there's a little pin. And you'll take the pin, put it into position. You'll take your small hammer and you will strike it until it goes all the way through. And that will break loose for your material to slide right out.